In this lesson, we're going to analyze stem and leaf plots and histograms. So let's look at what a stem and leaf plot is. Think about an actual plant where you have a trunk and you have, or a stem, and leaves grow out of that stem. So what a stem and leaf plot does, if you look at the one on your screen, it takes numbers. For example, in this one, if you look at the key, 8/3 represents 83. So in this first row right here, these values would be, this one would be 52 and this would be 55. Some important things to note is that as you move out to the right, your values grow. So they're in sequential order, there's no comma in between, and they're equally spaced apart. If a value is repeated, that leaf is there twice. We will look in a minute at back-to-back stem and leaf plots. But first of all, let's calculate the measures of central tendency from this stem and leaf plot. So this represents the test scores on a biology exam. So one of the things I do is I quickly count up how many numbers are included. So in the first row there's 2, second row there's 3, that's 5, and keep counting. That reveals I see a total of 20. So to find the mean, I need to find the sum of all those values. So that means I'm adding 52, 55, 66, 68, 68, etc. And I find the sum of the numerator, which I get 1,586, and I have to divide that by 20 to get 79.3. Now remember, it's a measure of central tendency. So that implies that my 79.3 should be somewhere near the middle of my data, and it appears to be. So that at least tells me that I probably didn't make an error. Now, the median is my middle value. So until you get good at these, it's probably a good idea to list them in order from least to greatest, which is simple to do. And then the middle value, if I check off from left to right, 52 and 100, 55 and 98, and keep moving towards the middle. Again, I had 20 numbers, so that leaves me with 2 in the middle, 76 and 76, so it's going to be the average of the two. Now, hopefully you know that when I add 76 and 76 together and divide by 2, I am once again going to get 76. So my median is 76. Now the mode is the value that occurs most often. So that value in this would be 76 and 94. They are both there 3 times. You can have multiple modes in a set of data. We're then asked to find the range, which is a measure of variation. So to find the range, I am going to take the greatest value minus the least value. So 100 minus 52 gives me a range of 48. That means all students scored within 48 points of one another. In the next one, I'm going to actually construct the stem and leaf plot. So I'm going to set up my stem and my leaves. So often we write stem and leaves over here. And I scan my data. My smallest number is 42 and my highest is 64. So my stems are going to be the 10s. So I'm going to use 4, 5, and 6, and I go in order. So 42 is my smallest. I put 2, 43, and 45. 50, 0, 61, and 64. It's always a good idea to put your title as well at the top of your stem and leaf plot. And I should include a key that tells me how to read this. So I'm going to say 4/2 tells me that this is 42 miles per hour. This next example is a back-to-back stem and leaf plot. And one of the things that's important to note is that just like a stem on a plant, the leaves grow out on the right, moving this direction. So your numbers on the right get greater from least to greatest. But on the other side of the plant, they grow out this direction. So your numbers get larger from least to greatest starting at the center. So notice that 1 is here and 2 is over here. Okay, now, what state produces more honey? So as I look at this, I notice that I have more values that are greater in California. So I stated that California produces more honey because they had 4 years that exceeded Florida's highest production. So Florida's greatest value was 24 million pounds of honey one year, where California had a 24, but then they had 28, 31, 31, and 32. So 4 of their years, they're producing much higher. And even their lowest value is higher. Now, which one's more varied? So when I say varied, think about your measure of variation. That's the range. So which one has a greater range? Again, I would say that that is California. California is more varied because their range is 18 million pounds. If I take 30, my greatest, 32 minus 17, actually I think that that is an error. That should be 15. 32 minus 17 is 15, whereas Florida's range is only 10 million pounds because you would do, their greatest is 24 minus 14. So California is definitely more varied when we look at the range. Now, let's look at histograms. And a relationship between a histogram and a stem and leaf plot, think of it as a tipped over stem and leaf plot. And this graphic illustrates it nicely. So I begin with this stem and leaf plot, and if I just turn it on its side, I kind of have a histogram, where this first value down here would represent a range of numbers from 0 to 9. The second one would be 10 to 19, and then 20 to 29, etc. So each bar is representing a range of values. So in this histogram, it's always good to read your title, your labels on your X and your Y axis. So students' travel time, it's representing the number of students that travel a span of values. So for instance, if I look at this value, this bar right here, this is telling me that 2, because if I look at the frequency, 2 students travel between 30 and 39 minutes per day. So the question is, number 1, how many students travel for at least 20 minutes to get to school? At least would be 20 or greater. So greater than or equal to 20 is what we're talking. Greater than or equal to 20 would be the last 2 bars. So 5, frequency of 5 and a frequency of 2. So 5 plus 2 would be 7 students. The second question asked me, is it possible to determine the length of travel time by the student with the longest travel time? Well, when I look at this, 2 students travel 30 to 39 minutes, but I don't know if the longest kid is 39 or if the longest kid is 30. So I would say no, we only know someone, or I would say 2 would be clearer. We only know 2 students travel 30 to 39 minutes. So there are some drawbacks to a histogram with how detailed your data can be. On this next one, let's compare 2 sets of data. So it's weekly study time. Looks like we're comparing 7th graders to 10th graders. We have the number of students or the frequency and how long they're studying. And it says which grade has more students studying 150 minutes or more. Well, this is pretty simple to see. Here's 150 minutes or more would be the bars here. 150 minutes or more, we can clearly see without even adding that 10th graders are studying more than 7th graders. And I would expect that. I would hope that that's the case, that 10th graders study more than a 7th grader would. In number 4, we're looking at the people born in particular months. So according to the histogram, how many people were born in October or later? So again, we're just kind of adding different bars. So October looks like 30, November looks like 60, and December is 20. So when we add this together, get 110 people. According to the histogram, how many total people were born in May? May would be 60. July is 60. September and November are also 60. So we could say 60 times 4 would be 240. And then number 6, according to the histogram, how many people were born in July? how many more people were born in July than in June. So we're comparing July to June. So July has 60 and June has 30. So if we subtract, that would be 30 more people.